Hello everybody, my name is Hamid Chraibi. I am a PhD student at Hassan First University, Morocco. My research interests include cloud computing, optimization algorithm, and embedded system. I'm here today to present a paper entitled Task Scaling Optimization for Cloud Computing using a new PSO initialization. The outline of our presentation as follows: introduction, motivation, and objectives, a background of the proposed work, result and discussion, and finally a conclusion. On one hand, cloud computing is considered to be one of the hottest trends in the IT industry. It applied an extensively distributed and high-performance computing paradigm that offers on-demand services, including network, server storage, and application as defined by NIST, the National Institute of Standard and Technology. The cloud computing offers three service models: the infrastructure, the platform, and the software. On the other hand, the task handling in the cloud computing. Task handling recently garnered substantial focus on the cloud computing. In such a process, the task scheduler accepts the queued tasks from the users. It assigns them to the available resources, taking into consideration the task's resource parameter. Recently, there is a considerable interest in the use of artificial intelligence technique, and especially the metaheuristic ones that have been applied to address the task scheduling, such as the PSO algorithm. The motivation of this work is find a new solution to schedule tasks better and in less time, which become one of the most exciting aspects of cloud computing. Users commonly use metaheuristic methods such as PSO for better task scheduling in terms of mixing as main the max spin as main metric used by the researcher. The max spin is the total time required to complete a collection of submitted tasks. We concentrate essentially on the initialization part of the PSO algorithm to enhance its execution. Particle swarm optimization is a stochastic optimization technique introduced by Kennedy and Eberhard in 1995, inspired by social behavior of fish scuttling or bird flocking. Its goal is to search for the best solution of a problem in the PSO algorithm. The process starts by generating a group of random particles and then search for the optimum in the problem space based on evaluating an objective function. In each iteration, the particle updates its velocity and position with the equation dependent on the parameter such as W, the inertia weight, the previous calculated velocity and position C1 and C2 learning factors, and R1 and R2 random variable in the 0, 1 interval. And the personal best which is the position achieved so far by a particle, and the global best which is the best value achieved so far by any particle in the population. The cloud sim simulator is a cloud simulation tool allow user to test modeled service in a controlled environment with different workloads and scenarios before deploying them in real clouds. It's composed essentially with from the data sensors. The resource provider include one or more hosts. The host, which is a physical machine that allocates one or more VMs. The virtual machines, which on machines on which the cloudlet will be executed. The cloud information service, which is responsible for registering all resources of data centers. The broker which assigned the task to available VMs based on resource and cloud list characteristics. And finally, the cloud list. In the cloud theme, all tasks and applications that are executed on the VMs. When using cloud theme, the cloud broker when using cloud theme, the cloud broker assigns the cloud list to the available cloud resource VMs using a scheduler algorithm. The main objective is to achieve the highest possible utilization of group of VMs with a minimum max spin. Find a best combination of the pair of cloudlet on virtual machines using the max spin fitness function to calculate the execution time of all possible cloudless combination on every cloud list source, and then return the highest execution time as the fitness value of the particle, where tvn is where tvmn is the execution time of running the set of cloudlet on a VM. The figure shows an example of the process using first come first serve algorithm where the number of VMs is 2 and the number of tasks is 7. Calculate in each VM the total execution time. Finally, we compute the maximum of both execution times, which refer to make speed. The proposed work. In this work, we propose a new scaling algorithm based on the PSO algorithm proposed early by Al-Olimet EIL in 2015. A heuristic alternative was considered to initialize the PSO algorithm instead of using a random initialization. This initialization was added to the PSO installer and integrated into the cloud architecture's cloud broker. The algorithm outlined the suggested PSO initialization. In the proposed HEPSO algorithm, every particle element in the matrix position encompasses two values, 1 and 0. 1 for all cloudlet assigned to a machine, a cloudlet E assigned to a machine G, and 0 for a cloudlet E not assigned to a machine G. For example, a matrix position of one particle with 4 machines and 8 cloudlets. Significant that the algorithm was iterated through all the cloudlets and allocate each one of the corresponding VM in VM. For example, the particle with index, for example, the cloudlet with index 0 assigned to the VMs with index 0 and so on. Result and discussion. In assessing the proposed study implementation, a simulation was incorporated with Cloud Simulator as part of a cloud broker using parameters described in the first table. One data center, 2 different hosts, and 5 virtual machines was created with the default characteristic defined by CloudSim in example 6 of the source code. Clouds were generated from a standard formatted workload of high-performance computing center called HPC2N in Sweden, with characteristics such as number of processors, the average used CPU time, used memory per processor, etc. PSO parameter taken from the paper Al-Olimet EIL, which our implementation is based on. The study implementation was performed and coded using Java. The HEPSO algorithm was compared against first come, first serve, and PSO. The comparison done using the make-speed metric in second. The simulation was developed for 6 different groups of cloudlets, consists of 20, 50, 100, 150, 200, and 400 cloudlets. The figure shows that the max spin was minimized when using our implementation, each EPSO compared to other implementation in different group of cloudlets and simulation, which will maximize the utilization and minimize the cost of using the on-demand cloud services. We can also see an improvement up to 24% in the 400 group of our HEPSO compared to PSO implementation. Conclusion. We proposed another implementation to solve the problem of task scheduling in terms of PSO execution. We underlined the effectiveness of updating the PSO to reduce the max speed metric. Our approach accomplishes the goal of decreasing execution time and the waiting time of users. We will improve our implementation and task execution time in future work by introducing additional quality of service metrics. We envision we envision concentrating our effort on development and upgrading additional scaling algorithm to attain the highest efficacy. Thank you.